According to literally everything we know about modern physics, you should not exist, I shouldn't exist, this microphone shouldn't, nothing should. See, in the first fraction of a microsecond after the Big Bang, the universe created matter and antimatter in exact, perfectly equal amounts for every single particle. An identical mirror-image antiparticle, and when matter meets antimatter, they violently destroy each other. Total annihilation. Pure, blinding energy. By all accounts, the universe should have erased itself the moment it was born. But here we are. Why? The context, okay, let's look at the facts. Physics doesn't play favorites. It's built on symmetry. Whenever raw energy converts into physical stuff, it always produces equal parts matter and antimatter. Always, no exceptions. We've tested this millions of times. Inside massive particle colliders, we smash protons together at nearly the speed of light. The result? A perfect, undeniable balance, every single time. In physics, this is the holy grail, CPT symmetry, charge, parity, and time. The rulebook says if you flip all three of these variables, the laws of nature stay exactly the same. The cosmic mirror is perfect, but if the universe actually followed its own rulebook, our reality is illegal. We are a mathematical impossibility. So where is the glitch? Deep dive. In 1964, two physicists accidentally stumbled upon a tiny crack in the cosmic mirror. James Cronin and Val Fitch were studying subatomic anomalies called kaons. Now, kaons are weird little chameleons. They constantly flip back and forth, oscillating between matter and antimatter. Because of basic symmetry, they should decay into other particles at the exact same rate, but they didn't. The antimatter version took just a tiny bit longer to decay. It was a minuscule discrepancy, roughly 0.2%. To the average person, 0.2% sounds like a rounding error. But to the world of physics, it was an earthquake. For the very first time, we had definitive proof that nature does choose sides. The universe treats matter and antimatter differently. Cronin and Fitch walked away with a Nobel Prize, and the scientific community finally breathed a sigh of relief. We thought, well, great, this tiny imbalance is the reason we exist. But then they actually ran the math. As it turns out, the asymmetry they measured in kaons is roughly 100 times too weak to account for the amount of matter in the universe today. It's like finding a single drop of water when you're looking for an entire ocean. Either we are missing something absolutely massive, or nature is hiding a much deeper, darker secret. Deep Dive 2. Enter Andrei Sakharov. In 1967, this Soviet physicist figured out the exact recipe required to build a universe out of nothing. He realized that for matter to survive the Big Bang, three specific conditions had to be met. Condition 1. The universe must have a mechanism that directly creates more matter than antimatter, a literal bias condition. 2. Matter and antimatter must behave differently when interacting. We already know this happens thanks to the kaon experiment, but again, the effect is way too weak. Condition 3. The early universe had to be cooling down and expanding so fast that the mixture couldn't reach a thermal equilibrium. Basically, everything had to be moving too fast for symmetry to fix itself. Think of it like a three-legged stool holding up our entire reality. We know the first leg exists, but it's too short. And as for the other two, we're still searching in the dark to prove they're even real. The three theories. So where are cosmologists looking right now? We have three prime suspects on the table. Suspect 1, leptogenesis. Maybe the imbalance didn't start with normal matter, but with ghosts. Neutrinos, nearly massless, invisible particles. In the extreme heat of the early universe, hypothetical, ultra-heavy neutrinos might have decayed unevenly, leaving behind an excess of leptons. This cosmic surplus eventually converted into the matter making up your body right now. The catch? We've never actually seen these heavy neutrinos. They only operate at energy levels we can't replicate on Earth. Suspect 2. Electroweak baryogenesis. Picture the infant universe cooling down. As it chilled, the electromagnetic and weak forces split apart, causing a chaotic cosmic phase transition.
Think of it like water freezing into ice.
Bubbles of new reality formed in space. Inside the walls of these expanding bubbles, the laws of physics might have favored normal matter over antimatter, trapping it inside. The catch? This theory requires the existence of completely new, exotic particles that our current technology hasn't detected. Suspect: grand unified theory baryogenesis. Back even further, to a time when all the fundamental forces of nature were unified into one singular, supreme force. When this superforce fractured into the individual forces we see today, it unleashed an unimaginable amount of asymmetric energy. The catch? The energy scale required to test this is 1 trillion times higher than anything our most powerful particle accelerators can ever achieve. We might never be able to test it directly. The search, but humanity isn't great at giving up. Right now, experiments across the globe are hunting for the missing piece of this puzzle. At CERN, the LHCb experiment is analyzing beauty quarks with terrifying precision. In Japan, the Bell-LaHoo project is colliding electrons and positrons to spawn billions of rare mesons. And deep underground in South Dakota, neutrino detectors like Dune are trying to see if neutrinos violate symmetry much more aggressively than anyone predicted. If it turns out that a neutrino is its own antiparticle, leptogenesis goes from a wild theory to our best explanation. The next decade of physics is going to give us an answer. Either we find the source of this cosmic bias, or we admit our model of reality is fundamentally broken. The human connection, when you strip away the complex math and the multi-billion-dollar particle colliders, here is what you are left with. The universe began in absolute, pristine perfection. Complete symmetry, but absolute perfection is sterile. It leaves no room for creation. If the cosmic mirror had stayed flawless, the universe would be an empty, cold expansion of nothing but fading light. Something broke that symmetry, a beautiful, unexplained imperfection. And because of that tiny cosmic glitch, you exist. Every single atom in your body, the carbon in your bones, the iron in your blood, it is all living evidence of a cosmic mistake. You are not a byproduct of a perfect system. You are the leftover debris of a broken one. We don't know exactly why matter won the war, but we are here to ask the question. I want to hear your thoughts on this. Which theory makes the most sense to you? Are we looking at a hidden property of neutrinos, or is there an entirely new law of physics we haven't even dreamed of yet? Drop your best theories in the comments section below. I'll be going through them and pinning the most insightful explanation. And look, if you think matter escaping annihilation is strange, just wait until you hear about the vacuum catastrophe. Because while we're busy arguing about matter, quantum physics proves that empty space contains enough raw energy to rip the fabric of reality apart at any moment. That video drops next week. Hit subscribe so you don't miss it. See you in the next one.